have a background, basic knowledge of inferential statistics, like what that is. But before moving on to this thing, I want to teach you another thing. That is called bivariate table. Okay, let me write down some frequencies out here randomly. Okay, so what does this 30 signify? There are 30 people who have the height of 140 to 150 centimeters and a weight of 50 to 60 kilograms, right? What does this 29 signify? 29 people have their heights between 150 to 160 centimeters and their weight between 60 to 70 centimeters, kilograms. Acha, another thing. I just added these 4 and just written 117. So what does this 117 signify? Sum of what? Sum of what? Yes, and what does that signify? I told you it's the sum. I just added these 4 and got this. What does that signify? It signifies that 117 people are there who have their height between 140 to 150 centimeters, irrespective of their weight. Correct? Let's add this up. 30, 5. What does this? What does this 118 signify? There are 118 people who have their weights, who have their height and weights of 50 to 60 kilograms, irrespective of their heights. Understood? So this kind of table are called cross table or bivariate frequency table. Projector, sir. Projector. I'll let the projection follow on this only. I can like draw that down. Acha. Say whatever this is, let's add it up. What does this 354 signify? I have added all these row totals. What does this signify? There is a total of 354 people. Understood? I have added all of these and got our row totals here, here, here and here. Now if I add all these four, I will get the total number of observations. No, there are 354 people, there is nothing here, right? There is nothing here. There are 354 people who have been studied, or there are 354 people who have been distributed over here in the terms of frequencies. Understood? Like, they have their weight from 140 to 180 and their height, and their weight from 40 to 80. Understood? Now I'll teach you how to do this on Excel. Password key. Mode of inferential statistics we were using. Testing of hypothesis. Correct? So, just like data, tests are of two types. One is qualitative, another is quantitative. What are qualitative tests? First, I'll give you some examples. Chi-square test, test of proportion. I'll just tell you the test statistic here because I will be using this mostly, or at least in our project. What are the quantitative tests? T-test, Z-test, ANOVA. We don't have this in our syllabus. I don't think we are going to do this, but still I'm going to tell you the test statistic, and I think we are going to do this, so we are going to tell you the test statistic. Solve. Now let's get the weight values. Oh, sir. Okay. I just took these numbers on random. But okay, what are we going to do? We are going to do the same thing. We are going to first do some serial number. How do we do serial numbers? We do 1, 2, this, we just fill up this much. We select these two and then we double click in the term. Okay. So we just draw the serial numbers. Okay. We don't have to write all of these, we just write 1 and 2 and then just we double click. Okay, then we just go to insert pivot table. Now for the table range, we just select all of the data. Okay. Now serial number always goes to values, and we change this from sum to count. Done. Height, say we take in rows, columns. We took height in rows only, and weight in columns. So this is the distribution. Now I don't like to do it like this. Let's group it. By grouping, what do we do? Understood? How we do a bivariate frequency distribution? So here there are two people who have their weights on. There are two people who have their weights on 45 to 54 kilograms and their heights from 120 to 132 centimeters, right? There are 4 people who have their heights 120 to 132 centimeters. There are total of 15 people. So now you know how to interpret this. Now you know how to do this. This will be very necessary in our project. So want to try it out on your hands? Put it in. Come on, anyone, someone volunteer. You have to do this on your own, right? Come on, come on, come on. Do that. Anyone else if you want? चले जा. Boss. Insert. Pivot table. Now select the whole of the data. Just click and drag. Yes. Okay. Just say okay. Yeah. Serial number goes to values always. First do that. Click here. Value field settings. Change this to count. Okay. Done. Now do weight on one side. First do weight here. Remove this. Anywhere you like. Yeah. Done. Just cut it. Not now. Cut it. So this is how you do a bias univariate frequency distribution. I taught you yesterday only. Yes. Click here. Anywhere. Yeah. On this row only. On this row. Anyone on this row. Just click anywhere on this row. Yeah. Right click. Group. Okay. Have it. Now select this. All of it. Till here. Till here. Down. And just go down. You got it selected here? Wait. Just shift and down. Yes. Okay. Click on Alt. Press on Alt. F1. What? Okay. I'll just do this. Have a diagram? So now you know how to do a diagram. So by descriptive is clear to everyone, right? I'll write down the steps once again. You go sit. I'll write down the steps once again for pivot table. Copy it down. Pivot table oblique frequency table. Write the values. First step. Second step, write the serial numbers. Go to insert. Then pivot table. Oh wait, but first you will have to do this. Select place for table. Like whenever we click a cell and then we go to insert the table, it will appear here only. Okay, so first we click the place oblique cell for table. Now insert pivot table. Then what? Select the values. With serial number. With serial number. God. serial number goes to values. Change value field settings. Is this, can you read this? It's very faint. Actually, it's the board. Value field settings. And what after that? Change value field setting. I'll give it what you have to do. Sum to count. Okay. Now, assign the variables. On rows oblique columns. After what? Okay. Then you can do click on row oblique column labels for grouping and finally select the values in the table finally we do Alt plus F1 for diagram. And the last step is you can right click on diagram plus and go to change chart type to change the type of diagram. I'll show you that. So now we know how to do a pivot table. So what are the steps? We have written down the values, we have written down the serial numbers. Now select a cell where do you want the table to have table to show up. Select a cell, any cell. Okay. Now what's the next step? Insert pivot table. Go. Pivot table. Okay. Now select the values with serial numbers, like select it total completely. Yeah. Okay. Okay. Now serial number always goes to values. Always to values. Click here. Click here. Value field settings. Count. Count. Go to count. Yes. Okay. Height in anyone you like. Weight in another. Cross it. Cross it. Click here. Right click. Group. Just do it. Same goes for that. Okay. So now you know. Get seated. Diagram is very easy. Just write type Alt plus F1. It's gonna work, right? So by various distributions we know. কি এখান দিয়ে এসে দাও লাগানো নয় লাগানো কেন হবে জোরে টানতে হবে now and the rest of descriptive statistics you can do on your own. I taught you the day before how to find average. Just insert with the formulas, auto sum, just go average. It's going to give you the average. Correct? This is the mean. How to find standard deviation? You just do this power. This minus this, dollar it up. variance standard deviation. What did I do here? These are the individual xi values. This is the x bar, correct? So what is this column? Is equal to power of xi, means whatever a2, minus x bar. What is a17? What does that happen? What does that do? It just gives you this xi minus x bar whole square, x1 minus x bar whole square. You get this, right? Power of 2, power of this difference. Understood? And then what do we do? We take the average. What is average? 1 by n and summation. So this is the variance, and after we square root that, we get the SD. Understood? This is how you do it compactly. Like, you can do this in 3 steps also, but that's not quite logical. Like, you can take the difference first, then do the square, then do the sum, then divide it by 15. Else you can just do it directly like this. Okay. So here we go. Till now it's clear. Now let's talk about testing. What is the characteristic feature of qualitative tests? Like qualitative data, we don't have any values out here, we just have categories and we have frequencies. Correct? So say a disease is prevalent in a place. A particular disease is in consideration. So some people will have the disease, some people will not have the disease. Say among the people, I have given some people a vaccine. And some people I have not given the vaccine. Okay? Some of them have the disease, some of them does not have the disease. Okay? So let's write down the frequencies. I have a problem out here. I can just write the exact values. Wait a second. দাও ধন্যবাদ পড়াতে লেখা মারধর করে লিখতে আর ভালো লাগছে না I have a very good problem out here. I'll just give you the exam, the values from that only. Open. Here 20, 52, 72, 180, 72. I'll calculate. No issues. 148. So, how many people were vaccinated? 200. How many were unvaccinated? 200. How many of them got the disease? 72. How many of them didn't get the disease? 324, 328. So, I am making a claim that the null hypothesis, I told you there should be a null hypothesis, the claim which we are going to test. So, I am claiming getting the disease is correlated or is dependent on getting vaccinated. Or I can frame the null hypothesis like this. There is some association between getting the disease and getting vaccinated. Whatever be the case, it's the same thing. We are just telling that whether getting the vaccine or not affects getting the disease or not. Understood? So this is a null hypothesis. What is the alternate? Alternate hypothesis would be they are independent. What is the alternate hypothesis here? There is no association. Till now understood? Now what were we supposed to do out here? So we were trying to find out a function of the sample whose distribution we know. Here the sample is, the function is given by chi-square is equal to summation OI minus EI divided by EI, and we put a square here. Now OI, what are OI? OI are these observed frequencies. পরে ফোন করছি। Now observed frequencies we know. What are the observed frequencies, right? What is the expected frequency? EI is given by row total into column total divided by grand total. So for this, what will be the expected frequency? 200 into 72 divided by what is the total? 400. What will that be? 36. Correct? What will be here? 272, 36. 200 into 72, 36. What will it be here? 200 into 328 divided by 400. What will that be? 164. Correct? What will be this in the, what will be the expected frequency here? 200 into 328, 164. Divided by 400 is 164. Understood? So we have the expected frequencies here. So how will the chi-square statistic look? 20 minus 36 whole square divided by 36 plus 20 minus, not 20, plus 180 minus 164 square divided by 164 plus 52 minus 36 square by 36 plus 148 minus 164 square by 164. Understood? You understood how this came? All of it? Everyone understood? What will this come out to be? 16 square by 36 plus 16 square by 164 plus 16 square by 36 plus 16 square by 164. Calculate and tell me the value. Whatever be it, we know the distribution of this. We know how this looks. I am not drawing the exact figure, but say let's suppose it looks like this. Let's suppose it looks like this, or the graph looks like this. Whatever be it, I am not drawing the exact figure. But wherever this lies, we know the distribution. So we know the 5% area above the point above which 5% of the area lies. Correct? If we know the mathematical distribution, we will know under which point there will be 95% of the area and above which point there will be 5% of the area. And so when we know this value and we figure this out, if our value goes beyond this, then our null hypothesis is not true. But if it falls on this side, then our null hypothesis is true. Understood? So, and now, another thing for chi-square, there is something called degrees of freedom of chi-square. What is degrees of freedom? Say this is the cross table. How many rows are there? 2. How many columns are there? 2. So what will the degrees of freedom? R minus 1 into C minus 1. 2 minus 1 into 2 minus 1, which will give 1. Okay. Now for chi-square distribution with degrees of freedom 1, we know this value is 3.841. Understood? So this value will change corresponding to the degrees of freedom. Okay. But for 2 by 2 table, we know that this point is 3.841. Now calculate this and see whether it goes beyond 3.841 or below it. Calculate this value. Huh? 30? हाँ तो ठीक है अच्छी একটু তো ভুল করেছিস বাবা 15.67 correct is 15.67 greater than 3.841 so what do we say oh sorry my bad one second how for I made a mistake out here. I just forgot that in the null hypothesis, the null hypothesis will always be independent and the alternate will be dependent. I just do the opposite. Okay. So it's independent on null hypothesis, independent on null hypothesis, no association on null hypothesis. Correct? Understood? So what will be our claim? What will be our conclusion? That since the value of chi-square is above 3.841, we can conclude that there is some degree of association, there are dependence. Understood? Because we have to reject the null hypothesis because it is greater than this. Understood? So what is the null hypothesis? That the null hypothesis was getting the disease is independent of getting the vaccine. Okay? But that is false, this is true. So there is dependence. Understood? Understood everyone? We find this value, we'll know this cutoff value, and if our value goes beyond the cutoff value, we will reject the null hypothesis. And what the null hypothesis will always be that these two variables are independent of each other, and the alternate hypothesis will be dependent. Understood? Rectify it. And also another thing, not here, you learn this till this only. You have to run the tests. Acha, tell me one thing. If this is 3.841 and our value comes out to be 15 point something, which is here. If we draw the line and draw this area will be lesser than this area. Okay. This area is called the p-value. P-value. If p-value is less than our level of significance, I told you what level of significance is. The amount of error we can allow. That is corresponding to this 5%, correct? So if p-value is less than alpha or 0.05, then also we can say that this is reject, this is accept. Understood? So chi-square test we have learned. Now how to do the chi-square test on Excel? Let's do the same let's take the same data. So what these data are? Yes, 20, 52, 180, 148. This is what we have. So let's draw the totals first. Now let's drag it. Let's do the same thing here. That's the totals. So let's make a column for observed frequencies. Let's just copy this down. Now let's do expected frequencies. What expected frequencies were? Row total into column total divided by grand total. And we do it accordingly. And after that, we know how to do the formula, right? Like I'll do the first line, you can do the rest. Power and we do the rest, do the sum, then we have the chi-square value. Understood? Now see, now I'll show you one thing. Say, what did our statistic come? 6. If you go to formulas, Moore's function, statistical, and then go to chi-square inverse, right test. And the probability, oh my god, why did I go for inverse? Chi-square dist, right test. If we put that x value here and the degrees of freedom here, we have this. What is this? 7.5 into 10 to the power minus z5. Way less than 0.05. Correct? So either ways we can draw the characteristic. If we say look more formula, statistical chi-square distribution right tail, and put x, this value as x. And what was the degrees of freedom? 2 minus 1, 2 minus 1, 1. So our p value is 3.11, 3.12 into 10 to the power minus 5. Yes. Which is like 0.00003. Correct? Which is way less than 0.05. Also correspondingly, this 17.34 is greater than 3.841. So both ways we can say that our null hypothesis was wrong. There it was that these two are not independent. There is some dependence between these things. Understood how to do chi-square test? Now, why did I teach you to do the p-value when there was only one? There was a normal distinct way. Because whenever we are doing it on computer, we don't have to look up for the critical value, right? We find this value and we just find the p-value. We know it's 0.05 and then we reject it. But whenever we are doing the sum on hand, like in third year, you will have to do it on hand, on pen and paper. In that case, you can never find out the p-value. For that case, you will have this, the cutoff value will be given, and then you have to draw your conclusion like that. Understood, everyone? Why the p-value here and why the critical value over there? Understood? Anyone want to do another one on the hand? Anyone? একজন চলে আয় ভাই আর তুই তো করেছিস অন্য একজনকে পাঠ you come do it. No, I'll just tell you these 4 values. Okay, you perform the sum, you perform the test. 10 here just right here only. No, 10 26 26 90 74 90 and 74 74 4. Do the sums, like do the totals. Do the total. Come here. Auto sum. Enter. Just drag this. Click on this. Go here. Drag. Done. Do the same here. Go for sum. Enter. Drag. All the way. Done. Write the observed frequencies here. Ah. 90. If you are afraid of using the computer, you need to be not. That's it. Come here. Now do the totals. Do the expected ones. Is equal to. Right? Is equal to. Right? Is equal to. This is not how you write it. This. Click on this. Into. There is an into sign over at this side. Start. That's okay. What is the row total here, column total here? This value. Because for 10 we are doing it, right? For 10 the column total is this. Multiply. Click on this. Just click on it. Divide the slash sign. Divide. Just the slash sign. Yes. This. Enter. You have it. Now do it for each and every one. You cannot drag it because this is in this structure and this is a linear structure. So just do it individually. Is equal to. Do it for 26. 26 has this as. Erase this. Is equal to 26. What is the row total? 100. This 100. Click. What is the column total? This 36. Multiply and give 36. 36 divided by. Enter. It will be 18 only, but yeah, do all of these, all of the 4. Is equal to. $90 के लिए करना है ना, तो remove this. Is equal to. For 90, what is the row total? This. Into what is the column total? This. See, if this is the cell we are taking into consideration, what will the row total be? Whatever the total is here, what the column total will be? Whatever the column total is here, had we taken this, the row total would have been this, the column total would have been this. Had we taken this, the row total would have been this, the column total would have been this. Okay, for 90 what? This and this, multiply. Into. Divide. 200. Done. Then last one will also be 82, but do it. Is equal to. What is consideration? 74. So that 100. Yes. Yes. Into. Divided by 200. We went there. You have it. What is the next step? OI minus EI divided by EI. Correct? Just do is equal to here. Is equal to power. Bracket. Just give a bracket. No. Yes. Another one. Another bracket. Yes. This. Click on this. Minus this. Close the bracket. Comma. we have to do square, so 2, bracket close, divide this, click this out again, yes, bracket close, no bracket close, just give enter, here, just drag it for this 4, just drag, bas, do the sum here, auto sum, enter, you have it. Now click on this, click on, no, just click here, formulas, more functions, statistical, chi-square, this right tail, yes, this value here, just click yes, what is the degrees of freedom here, 1, click here, 1, see, just put 1, okay, what is this, less than 0.05, so what can we conclude, that there is dependence between this and this, understood, everyone understood how to do it? So chi-square test is no problem, even if we had one more category, say we had another category, say has some other complications, another category. Okay, then we would have done the same thing, just sum would have been increased, and the only thing that would have been different is here now there are 3 column categories. So this would be 3 minus 1, which will give the answer to be 2. So the degrees of freedom would have been 2. Understood? How things just change, and for that the cutoff values will change, the p values will change. Understood? So everyone is used to doing these tests, like know how to do, what to see or what to see. Good. This is the p value, this is the chi-square value. This is the p value, this is the chi-square value. Understood? Wait a sec, 0.05, enter. See, if and also if we wanted to compare this, like if chi-square greater than 3.841 or not, or greater than critical value or not, what do? We just write 0.05 first, written, that is the cutoff value for the critical point, that is the p value for the critical point. Now what? We go to more functions, statistical, chi-square, inverse right tail, okay, and do the same thing, just put this as the probability and degrees of freedom as 1, just the opposite way. What's a plus? Understood? So also again from this we can conclude that this is greater than this. But why did I teach you this? For 1 I can remember, for 2 how will I remember, for 3 how will I remember, for 123 how will I remember, correct? What will I do? I'll just put the degrees of freedom and accordingly say 12. I have the value. Understood? Say for 12, I have the p value. Understood? How the degrees of freedom is changing everything. Our conclusions are also changing. Understood? Our null hypothesis is that getting the disease is independent of getting vaccinated. And the alternate hypothesis, they are dependent, or there is some sort of association between them. So for changing degrees of freedom, we can see the cutoff points are changing, and so our conclusions are also changing. Understood? So we have to be very specific on the degrees of freedom. Understood? So till now, till this we have the chi-square test. Everyone understood everything? No problem? Anyone have any doubt? Please say up. Anyone? Nothing. Okay. Now I'll just write that test statistic for t-test and it's over today. Quantitative test. Here we have values. So we can what can we compare? We can compare the means. So what like say we are studying a change in a body after administering a medicine. So say we have 150 people whom we have given the medicine, and another 150 people whom we have not given the medicine. Okay, and we have seen in say like in 1 week how much weight they have all of them gained. Okay, and now say we have 150 people and we have 150 values of weights here, 150 values of weights here. Okay, and we are claiming that the average weight here and the average weight here are the same. If that is the case, then the medicine is not effective. Correct? So our null hypothesis is this. Mu1 is this average, and mu2 is this average. Understood? And alternate hypothesis is mu1 not equal to mu2. Then we will see what happens. Correct? Also, we can do another thing. We can have 150 people. First, we can take their weights, and after giving the medicine and for 1 week, we can take their weights. But what is the difference between these two scenarios? Here, this weight has no correspondence to this weight. Correct? Even we might not have 150 people out here, we can have 130 people out here. Possible. But here, the weight of the first guy will be correlated to the weight of the first guy after giving the medicine. Like he was 150 kilograms, 50 kilograms. How do I expect him to go to 20 kilograms after the medicine? No, it won't happen. He was 50 kilograms, he won't go to 100, right? The guy who was say 80 or say 90 is more likely to go to 100 than this guy, correct? The guy who was 15 is more likely to go to 20 than this guy. So there is correspondence. There is the same guy who was weighted before giving the medicine and the same guy who was weighted after giving the medicine, correct? So in this case, we will use the 2 sample T, and in this case, we will use the pair T. So I will just write the test statistic and the degrees of freedom, nothing else. For 2 sample T, and for pair T, understood? First, let me write the degrees of freedom, then I will write the standard errors. The degrees of freedom for T distribution for 2 sample T is given by N1 plus 1, N1 minus 1 plus N2 minus 1, which will give us to be N1 plus N2 minus 2. Understood? And see, as these are correlated and they have equal number of people, because obviously the same people were interviewed before and after. In that case, the degrees of freedom would be given by N minus 1. So let's calculate the degrees of freedom here. 150 plus 130 minus 2, 278. Correct. What is the degrees of freedom here? 150 minus 1, 149. Understood? Now for the standard error part. Wait, I'll rub the board and write it. It's a big formula. Okay, we draw these formulas, we derive these formulas, take out a value and do the same thing here. The same way we do the chi-square statistic test, the same way we do this. We go to more functions, statistical, just like chi-square we have t. Understood? But one thing, always use 2t, 2 tail. Okay? Understood everyone? Everyone understood? More functions, statistical, see you have t distribution. Just find the value, t dot distribution dot 2 tail, you have your answer. Understood? You have your p value, compare with 0.05, you have your answer. Understood? Now for SC standard error of d bar. First let me tell you what is d bar. There is correlation, same person. So we just find out the difference in the weights. Like the same person was 50 kilos before, he became 52 kilos after. So what is the difference? He was 50 kilos before, he became 48 kilos after. What is the difference? -2. So, so these are the differences. We just add these differences up, divided by n, we have d bar. SD d bar has a separate formula. This is applicable only for testing, not in descriptive statistics, only for testing. The formula is 1 by n minus 1 summation di minus d bar whole square. Okay, same as standard deviation, just n minus 1 here. Understood? And after that, standard error is given by this. Understood? Find standard error of d bar, find d bar, put it here, get the t value, do the same. Understood? Now the null hypothesis will be like this. The mean of this population is equal to mean of this population versus these are not equal. Understood? And if there is significant difference, then the medicine is working. If there is no significant difference, then the medicine is not working. Understood? All of you? Sure, everyone? Everyone is convinced how to do it? Understood though? Keep this in your mind, you will not have to study this again in 3rd year. Else you have to like mark this up, this is very difficult. Can I rub the board? So I'm not like telling you the other tests because most probably those won't be used. The proportion test, the Z test, those won't be used in your project. Maximum this much will be used. What will we do? We will draw the sample size using the Taro-Yamane formula I told yesterday, the day before. We will draw a sample size using the Taro-Yamane formula n by 1 plus n square. We will get a formula for sample size 120, 112, something like that we will get. We will draw the sample, like we will go to the OPD, take this many data, put it on Excel, and then we will consider our research study, like what are we trying to find out. So if that suggests we need to find out whether this particular thing has a influence on another thing, then we will do chi-square. And if we want to see whether the average of this, say we have two groups, average of this group is significantly different or not from the other group, then we will do t-test. Understood? Nothing else. And after that we will draw our conclusions, put it on the PPT and present. Understood how it's going to work?